I always find these folding questions quite interesting, although challenging too. We're told that we've got a rectangular piece of paper, FGHI, side lengths of 4 and 16. And then it's folded along MN so that G goes on to I. The outline then makes a pentagon. So this is what we're trying to find the area of. Okay, so I said in this question, right, I'm going to label this X, and then this will be 16 minus X, because the total amount is 16. But that length mg is folded inwards, which means this is also 16 minus x. And that immediately gives us a right angled triangle where we have three sides in terms of x. We can use Pythagoras' theorem. 4 squared plus x squared is going to be 16 minus x squared. So 16 plus x squared is 256 minus 32x plus x squared. These two cancel, leaving 32x as 240. I'd divide it through by 8 first of all, so 4x is 30, therefore x is 15 over 2 or 7.5. Okay, so that is really useful because immediately I've got um, the area of this green triangle is going to be half times 4 times 7.5 is going to be 15. Now, I didn't really want to make the same assumption that this is definitely X, although it turns out to be, but I used a similar sort of approach. I said this is Y, and then therefore this is going to be 16 minus Y, and this here must be Y because it H dash N is the same as NH when you fold it. And finally, this is 4 because actually it's the same as HG. So we can make the same argument again to say that Y is also 7.5 and showing they are actually the same, which means that this area here is also 15. And I'm just left to find the area of the non-shaded triangle. I'm going to shade it in orange now. But what I can see is that this 16 minus 7.5 is actually going to be 8.5. Then I can use a half base times height here because this is 4. So 2 times 8.5 gives 17. And therefore our answer is going to be 15 plus 15, 30, plus 17, giving us 47. You could instead just find the area of the trapezium, like this bit here. It's worth knowing this formula, so I'm going to talk about it. In fact, I'm going to focus on the trapezium here, which is exactly the same, just because it's like normally drawn a bit like that. Okay, so we've got 4, and then 16 minus x is 8.5, and then 7.5 here. So the area of a trapezium, and you have these two parallel sides, is you add the two together, and you have it. Divide by 2, kind of gives you an average, and then you times by 4. So it's going to be 16 over 2, 8, 32. Okay, so you could just get this as 32 and then add on the 15 you prefer. To be honest, that's how I did it originally, but finding the area of the triangles works as well. Anyway, nice question, and yeah, well done.